All right, hello everyone. This is Sir Crozier, and I'm going to go over review packet 1 for the AP test. All the answers are here, and I'll just try and give you some help. First one, well, we have a function's position, and we need velocity. So just remember this: order, position, velocity, acceleration. You take the derivative, you go down that ladder. If you integrate, you go up the ladder. So I'm at position, take the derivative down to velocity, and then I plug in 3, and that will give me the velocity there. And then then it says, where am I right or left of it? Well, if you plug in 3 up here, you're going to get 12. And if you plug in 0 originally, you're going to be 3. So this originally starts at 0, 3, and then it ends up at 12. So it's right of where it started, and the velocity is 12. Average value, you integrate and divide it by 4 because that's the range. Remember, you're doing the average, so you want to take this total divided by 4. We did this one in class. It's a new rule saying that if you end up with a 0 over 0 after direct substitution, you can take the derivative of the top and bottom, then plug it in. Number 4 is an area problem, but what you're going to notice is these are overlapping. So we have one area where the f function is on top, in the other area where the g function is on top. So you're going to do 2 separate integrals and then evaluate and add them together. Number 5 here, you want to simplify it down, and the only thing that matters is the front end because we're going to infinity. So the smaller stuff does not matter. And then if you take the square root here, the square root of 9 is 3. Infinity squared square rooted, well, that's going to be a positive infinity right there because squaring it's going to make it positive. Square root is going to make it back to infinity, but it's negative on the bottom. So it's a negative 3/2. Polynomial, if this is our derivative, wherever it's 0 is where we have a point, and that's where we could have a change in a min and a max. And I went ahead and did the signs here. Function goes down, up, down, up. There's my 2 minimums. The absolute minimum value occurs when the derivative is equal to 0. So I took the derivative, found it equal to 0 at 0. So here is a value, and also I have to check the endpoints. Remember, when you're looking for an absolute maximum, it happens at the endpoints or when the derivative is equal to 0. So we have this value here, and we go down that way. And this one is the highest value there. Number 8, it's a proportional relationship. So proportional just means I times it by k. And if you read this up here, you will get those 2 other values. So the change in the population with respect to time is proportional to this. Intermediate value theorem means that I know at this point in time the output is -2, and at this point in time the output is +2. So somewhere between these 2 numbers, this line has to cross 0. If I were to graph it, I would be at -2 at one point and +2 at one point. No matter what happens, it crosses that axis, and that's the intermediate value theorem. Somewhere between here, there has to be an input that has an output of 0. This right here is the limit definition. This definition means that I have the function 8x cubed right there. You should be able to see that 8x cubed minus 8x cubed, and I'm taking this derivative and I'm using the point 3. So I'm putting a 3 there. And if you take the derivative, you have this, and you put in a 3, you have 216. Just some integration, working backwards. Don't forget about this 2. Comes from the chain rule. If you can't do that in your head, do some u substitution here. Let u equal 2x. Volume of a cylinder is this formula. If I take the derivative with respect to t, I have all of this. Now, what is this? Well, this is my left function, right function. Left, d right, the derivative here is dh dt, plus right, d left. The derivative here is bring down the exponent to a 2, subtract it to a 1, and do the derivative dr dt. And now you have all of these values here are listed up here somewhere, comes down to negative 20 pi. Chain rule, left d right plus right d left. Particle moves along the axis. Well, if we're, and again, here is a PVA, and we have to go back up. We integrate this acceleration here, and we have this. Then we take this and then we plug in the value for c, figure out what c is. Then we take this and we integrate it back. We just keep integrating up the ladder. Integrate, figure out c. Integrate, figure out c. And then once we figured out c here, we can plug in that and find the output there. Number 15, derivative of secant is secant tangent. Unit circle will get you here. Number 16, we have a function that says g of x is this integral. G of 3 goes there. I want the area from -2 to 3. Well, those are geometric shapes, so you can find them that way. Second derivative here, take the derivative down there. 18, it's smarter to FOIL this, and then you have this, and then you can integrate it. This needs to be directly memorized. That is implicit differentiation. If you have dy dx, or t is equal to cy, it just becomes y equals ce to the kt. Sorry, that's a k. That just needs to be burned into your brain. That is a rule that you memorize. If you remember how we did that, well, we put this over here and we divided this over here. Remember, our first step in this is to divide this y over here and to put that dt over there and then finish that problem. But by now, we don't finish this problem anymore. We have it memorized. Number 20, h of 8 is 5. The derivative is 0. That means there's a tangent. And this is concave down, -4. That's a maximum. It looks like that. Answer key is wrong here on that one. It said minimum. On this problem here, it's some integration. You could plug that in your calculator to check it, but do it without a calculator. It's going to take some U substitution to keep track of the chain rule. 2 ninths. Number 22, a great problem right here. This is a fundamental theorem of calculus problem. We're supposed to integrate a function that we don't even know. But that's fine, because what this means is if I integrate this backwards, I go back to the original function and just do, like we wrote in class a lot of times, f of 3 minus f of -2. But they tell us what the big function is. It's kind of a backwards problem. We don't know the derivative problem, but we do know the original. So we use the original. This tells us to do the fundamental theorem of calculus. And then we do it using that, and we have this value here. Dy dx, well, take the derivative. Well, I simplified this down into these two things right here because that's over that and that's over that. And then I just plugged in 1 once I got the derivative there. Here's the graph. State the interval where g of x is greater than 0. So I want everything above the axis, not that direction. I want g of x to be increasing. I want it to be going up. Well, it's going up from about right here this way. So all of this is going up. This is going up right there. There's an up section. There's an up section. If I were to highlight the sections that are going up, this is all going up, and that's all going up right there. But what do I want? I want where it's concave up, and that's only this section right here. This is concave down. The second derivative here is negative. The second derivative here is positive. Positive is cup going up like this. Negative is cup going down like that. So I only want that section from 1 to 4. We did this one in class. It's a little bit complicated, but you take this original function, divide it by that function, and you have this here. And now after you have this here, you can integrate it into here. And a washer problem. If this is revolved around this line, there are washers, and there's the outer radius, which is 4 down to there, and there's the inner radius, which is 4 down to there. One line in your calculator, and you have it. All right, hope this helps. If you have any questions, please ask in class. But these are difficult problems, but they will get you ready for the AP test.